Today we're going to finish up lesson 103 that we began yesterday about this process of dividing with our radical expressions. Just to review some things that we discussed during yesterday's lesson. Remember, the goal is we're trying to rationalize a denominator. What did that mean? That we're trying to rationalize, we are trying to remove any radicals that we have from the denominator. A question is not considered to be simplified if you have some sort of root, whether it be a square root or cube root in the denominator. We are just focusing on questions in our lesson that involve square roots, and the same thing will apply in our lesson today. We saw yesterday the correct process to rationalize was we multiplied both the numerator and denominator by the exact same piece, which means you're multiplying really by 1 in the question when you have a fraction with the same part on both the top and bottom of the fraction. Well, in yesterday's lesson, we saw that you just had an individual or a single square root in the denominator, and you would multiply by the exact same square root. Like if I was trying to get rid of a square root of 5 in the denominator, then I would multiply both the numerator and denominator by that square root of 5. The reason that we did that was a square root times itself really means you're squaring. The opposite of a square root is to square, and that allows the radical to disappear from the denominator. Well, what's going to be different in today's lesson? There is still a radical that we have in the denominator, but now we also have a plus or a minus sign. The denominator now says 2 plus square root 3, or it says square root 5 minus 1. You have that extra piece that is in the denominator, and because of that adding or subtracting, we can't use the same process that we learned yesterday about just multiplying by the same square root, and that's what we're going to learn today. How would we simplify that kind of question? Now, to help us understand that, there's a word, I can't remember if we've talked about it already this year. We may have just mentioned it briefly. It's the word conjugate. In math, a conjugate looks like the following: A plus B and A minus B. What do you notice is the same between those two expressions? They both contain an A at the beginning. They both contain a B at the end. What's different about these two expressions, one of them is a plus and one of them is a minus. That's what it means that you have conjugates. You have the exact same two terms, but there's different signs that you have in the middle. So something just to give you examples like we talked about before. X plus 2, X minus 2. They have the same pieces. One of them is a plus, one of them is a minus. Well, what we're going to see in our question today is we're going to have to deal with conjugates for irrational numbers, because remember, irrational numbers are things that involve our square roots. Well, the conjugates would just look like this: A plus your square root of B and A minus the square root of B. Notice once again, you have the exact same two pieces. The A is first, then the square root of B. The only thing that is different is that plus and the minus sign that you have in the middle of your question. So if I had a problem that said 5 plus square root of 2, the conjugate would be 5 minus square root of 2. We leave the two terms alone. We only switch out the sign that is in the middle of the question. So this idea of our conjugates is what we're going to use today to help us simplify a question that has some sort of root in the denominator as well as a plus or minus sign. So your conjugate is going to be used to rationalize the denominator. Again, to rationalize means you're trying to remove the square root. So the conjugate is going to allow you to rationalize the denominator when the denominator is a binomial, which means you have two terms down there, and at least one of those terms is some sort of radical sign. That's an expression like if you had 2 plus square root 3. On the questions that we're going to be facing here, the two examples that I'm going to walk together with you, only one of the terms has a radical, like 2 plus square root 3. This process would also work if they were both radicals, like square root 7 minus square root 2. But let's just go with just one radical in our denominator. Again, I can't just multiply by the same radical because of the plus and the minus sign. I have to multiply by this idea of a conjugate. Now, why do we have to do this new idea of a conjugate? When I multiply by a conjugate, the radical disappears. And that's what I want to happen in the question. If I only multiply by just the same square root, you're still going to have a square root in the denominator, and that is not what you want to happen in the question. But if I multiply by this new idea of a conjugate, then I'm going to be able to remove the radical symbol. Let me show you that's true on the following multiplication problem, and then we'll work through our examples together. If I had wanted you to multiply 6 plus square root 3 times 6 minus square root 3, those two expressions are examples of conjugates because they both start with a 6 and they both end with a square root of 3. The only difference between those two expressions, the first one has a plus and the second one has a minus. Now, everything that I've said so far, the plus is always first and then the minus is second. That doesn't have to be the case. The minus could have been inside the first parenthesis and then the plus in the second parenthesis, and that would have been perfectly fine. Well, how have we learned to multiply a binomial times a binomial? We FOIL. So the first terms, 6 times 6 gave me 36. The outside terms, I have 6 times negative square root 3. Well, a positive times a negative was negative, so I have minus, and 6 and square root 3 can't be multiplied together because one of them is in a square root and one of them is not. So I just have minus 6 square root 3. When I go to the inside terms, we have positive square root 3 times 6. Once again, those can't be multiplied together because one is a square root and one is not. So we have plus 6 square root 3. The last terms, positive square root 3 times negative square root 3. Well, we know that a positive times a negative gives us a negative. So there's my minus sign that I have in the question. Well, here's like the arithmetic that we saw yesterday, square root 3 times square root 3. Since they are both square roots, we're allowed to multiply them together. So 3 times 3 is 9, and the square root of 9 is 3. Like I showed you yesterday, anytime that you take a square root times itself, the square root part cancels out because technically you're squaring, and you're just left with the radicand piece that you have, which is the number 3. Notice what we have now in the question are some like terms that we can put together. We have this constant in the front of 36, and we have this constant in the back, minus 3. Those we can put those two together. The pieces that are in the middle both have a square root of 3. Therefore, they're like terms. That's what it meant. You had like terms for radicals. They had the same part on the inside for the radicand. Well, notice what we have. The first one is negative 6 with the square root of 3. The second one is positive 6 with the square root of 3. When we added and subtracted, we only combined the coefficients or the numbers in the front. Negative 6 and positive 6 is 0. So these two pieces cancel out, and notice I've completely eliminated the part that had the radical, which is going to be the goal in our lesson today. So what do I get when I subtract the other two numbers? It is 33. So notice in the question, the outside and the inside terms canceled each other out in the FOIL method. And that's always going to happen because those pieces would always have the opposite signs on them. One of them is going to be positive and one of them is going to be negative. So really, as we're working through these questions today, when I go to multiply with these conjugates, we just have to do the F for the first terms and the L for the last terms in the FOIL method. I really don't need to do any more the outside and the inside since they're the exact same pieces with opposite signs, and I know that they're going to cancel out in the question. So let's see if we can put this idea together as we're attempting to simplify or to rationalize these two questions. My first problem, 4 over 2 plus square root 10. I know this question is not simplified because it has a square root that is in the denominator. Again, please do not just multiply by the square root of 10 because that is not going to work to rationalize this question. Also, do not reduce with the 4 and the 2. Yes, 4 and 2 have something in common, but that 2 on the bottom is part of an addition problem. I need to keep that 2 as part of the addition problem. It can only cancel out with the exact same addition question. So how am I going to approach this question? Because of the adding that I have in the denominator, and it also has a square root, we need to use this idea of a conjugate. So I'm using the same two pieces, only switching the sign in the middle. That's what I would multiply both the numerator and the denominator of our fraction by. So I'm going to end up multiplying here by 2 minus square root 10 to both the top and bottom of our fraction. Just like we saw yesterday, whatever I do to one part of the fraction, the same thing has to happen to the other part of the fraction as well. Something that might help you guys as you're working through these questions, since these have two different terms, if you want to go ahead and put parentheses around them in your question, you're more than welcome to do that. Usually I don't, but that might help you guys as we're learning these kind of questions. Well, let's take a look at the numerator. In the numerator, I have 4 times this subtraction problem. Well, how do I multiply a number by a subtraction problem? We're going to distribute. So 4 times 2, and then 4 times our negative square root 10. When I multiply that out, 4 times 2 would give me 8. And then a positive times a negative gave me the negative, so there's my minus sign. And 4 times square root 10 is just 4 square root 10. I can't multiply those together because one's a square root and one is not. Well, let's go ahead and move down to the denominator. In the denominator, because I have my conjugates, I can do that little shortcut of just multiplying the first terms and just multiplying the last terms. Again, why can I do that? Because the outside and the inside terms match, but they just have opposite signs. They would cancel each other out. So the first terms that I have in the denominator is 2 times 2. What's 2 times 2? 4, and I have that in the denominator of my new answer. The last pieces that I have are square root 10 times negative square root 10. Well, positive times negative is going to be a subtraction sign. The sign that you have in the denominator of your fraction is actually always going to be a subtraction sign after you multiply, because you're always going to be multiplying a positive and a negative number together for those last terms. What is square root 10 times square root 10? Well, technically, it's square root 100 from 10 times 10. And what is the square root of 100? It's just the number 10. There's our little shortcut again. A square root times itself is really squaring. So square root 10 squared, the square cancels the square root, and I'm just left with the number 10. Let's continue in this problem to see what else we can do. The numerator has 2 separate pieces, our 8 and our 4 square root 10. Those 2 pieces are not alike because one has a square root of 10 and one does not. Well, let's go to the denominator. We have a 4 and a 10. Well, those are just regular numbers. We can subtract them. So my numerator stayed the same, 8 minus 4 square root 10. The denominator, 4 minus 10, is negative 6. We know anytime that we have a fraction, we always want to simplify as much as we can in the problem. We've done the main goal that we correctly removed the radical from the denominator, but I still have to follow anything else that I know about fractions, which is reducing. Now, how do I know if I can reduce a fraction like this? I need to look at the numbers that are kind of the same. And what I mean by that are the numbers that are not inside of the square roots. Well, what numbers do I have then? I have an 8, a 4, and a 6. All 3 of those numbers are not inside of square roots, so let's take a look at those 3 numbers. 8, 4, and 6 could all divide by 2, so that's something that I would want to do in this question. Again, I'm not looking at the number 10, because the 10 is inside the square root. It's its own kind of number in the question. 8 divided by 2, well, that would turn this into a 4. 4 divided by 2, that would make this a 2 right here. And 6 divided by 2 would make this denominator a 3. Now, one other thing I would like you to do to your final answer. It's usually not customary to leave a negative in the denominator of a fraction. So what I'm going to do is I'm going to take this negative and I'm going to move it up to the numerator. Now, when I do that, listen carefully here, the numerator has 2 separate pieces, the 4 as well as the minus 2 root 10. The minus, or the negative, that I'm moving up to the top affects both of those numbers. So my positive 4 is now going to be a negative 4. My minus 2 square root 10 is a positive 2 square root 10. It's like I distributed that negative into the numerator, just like I distributed the 4 earlier in the question. So I took the negative out of the denominator and I moved it up to both pieces that are in the numerator, and that just leaves me with the number 3. At this point in my question, 4, 2, and 3 don't have anything in common. I cannot combine those numbers in the numerator. There's no square root in the denominator, and my question is completely simplified, and that would be my final answer. Now, one thing I do just want to point out here about the final answer, when you guys take like your standardized test and eventually someday when you take your ACT and SAT, they might write the answer like this. Well, how did they come up with this answer? All that they're doing is breaking our problem into two separate fractions. They have the -4 from the numerator over the 3. There's the first fraction, then there's the plus sign, and then the second term, 2 square root 10 over 3, there's the second fraction that they have. I am perfectly fine with you giving your answer like this one on the top with one giant fraction, but it is okay if you want to make it two separate fractions in your final answer. Let's try one more example together today. We have 6 over square root 7 plus 2. Again, this question would not be considered simplified because we have the square root that is in the denominator. We cannot just multiply by the same square root like we learned yesterday because this question has a plus sign as well in the denominator. Do not, again, reduce with that 6 and the 2 because the 2 on the bottom is part of an arithmetic problem. It needs to stay part of that addition question. So what should I multiply by to rationalize this problem? I'm going to multiply by the conjugate, which is square root 7 minus 2. I used the same two pieces, I only switched out the sign that is in the middle. Like we did on the last question, if it helped you, go ahead and put parentheses around all those pieces that have the double terms. That way we can think about what we're doing as we're next going to do our multiplication step in the question. The numerator is the same process that we just did on the last question. This 6 needs to get multiplied by the second numerator. Well, how do I do that? I need to distribute into the question. 6 times square root 7, well, those I can't multiply together, so I would just have 6 square root 7. 6 times -2, well, that I can do, and that would give me -12. So I have 6 square root 7 minus 12. In the denominator, here's our conjugates. Because we have conjugates, we know the outside and inside would cancel each other off, so I'm just going to do the first and the last pieces of our FOIL method. The first terms, square root 7 times square root 7. Well, again, technically, that's square root 7 squared. The square and the square root cancel each other off, and I was just left with the number 7. Again, if you're not quite sure on that, square root 7 times square root 7 is square root 49. Those you can multiply together because they're both in square roots. Well, what is the square root of 49? Is just 7, and you got the same answer as well. Let's go to the last terms. You have a positive 2 times a negative 2. What's a positive 2 times a negative 2? A negative 4. Notice once again, we have the subtraction sign in the denominator. Always going to be the case there because you're always going to multiply a positive times a negative for the last pieces of your FOIL method. Let's finish up with our simplifying. The numerator does not have like terms because of the square root 7 that is on the 6. The denominator, however, does have some like terms. 7 minus 4 gave me 3. We've done the main goal. We've removed the square root that is in the denominator, but let's check to see if we can simplify this fraction. Again, to do that, we are only looking at the numbers that are like numbers. They can't be inside of the square root. What are those numbers? 6, 12, and 3. Well, all of those numbers do have something in common. They would all divide by the number 3. 6 divided by 3, that would leave me with a 2 right here. 12 divided by 3 would leave us with a 4, and 3 divided by 3 would cancel out to the number 1. What I have in the denominator is just 1, so I really don't need the denominator anymore, and our final answer is 2 square root 7 minus 4. I cannot put those two terms together because one has a square root and one does not. So what we learned today, if I have a binomial, which means I have two terms in the denominator, one of them involves a square root. If you're going to simplify or if you're going to rationalize, you have to multiply by the conjugate. What is a conjugate? The exact same two pieces. You only switch out the sign that you have in the middle.